you about the substance, right? Well, if you have a steeper slope, for instance, let's say you have over here, we'll make another line. We'll say that this right here is our initial line A, and we have a different line, which is a different substance that was measured, as well as our broken up tabletop. But this one's line looks like this. And we'll call this B. And then we have yet another one that kind of close. There we go. We'll make this green for fun, just to get some difference. Okay, so there are three substances: our original A, and then we added in substance B and substance C. Okay, so of these three substances, which would we say has the greatest density? I'm saying how much, but which, what? B, right? How do you know that, Maddie? Right, because it has the bigger slope. So the larger, remember, slope is density. So if the slope is higher, it's going to be a higher density. All right, so then, that being the case, it has the smallest density, C, right? And then B is in between. Right, so again, you can just see that on the quiz or something. You get a graph, and there's 3, 4, 5 lines on there. And say, okay, which of the ones on the graph above has the lowest density? Which has the highest density? Right? No big deal. Right? You have to read the graphs. Really important. You can't tell by now. I really like graphs. You're going to see graphs a lot in here. All right? So if you're a visual person, that's a good thing for you. All right? Now, one thing too that you're going to see too is, let's say substance A is water. Okay? And you take substance B and you throw it into the water, what's going to happen? What? Get it? What? Luke? Did you say it? Somebody did.
It's going to sink.
It's going to sink, right? Things with higher densities than water, when you put them in water, they sink. So then substance C would float. No matter how much you put in there. It doesn't matter how much of the substance there is. What matters is the density. Well, you could have like a big old tree fall into a river, and it floats on down the river. Even though it's probably 1,000 whatever pounds. Doesn't matter. What matters is that density. Whereas you can take a little tiny pebble, throw it in the river, and it'll sink right to the bottom. Because its density is greater than the water. All right? But that's one use of these graphs is they'll put things on there and they'll put water there at that middle one. And then you'll be able to tell just by looking at it if something sinks or floats. And by how much, right? So the closer that line gets down there by C down towards that x-axis, the more it floats, right? Because some things, like you put them in water, they kind of sort of float because they're close to the density of water. They're a little bit less. And others is like, in the pool, you get a ball and you push it all the way down to the bottom and you let it go. Those balls have really, really low density, so it goes right up to the surface. So the difference is great. Okay? So it's not like either it sinks or it floats. There's some gray area there. Okay. Questions on that? Everybody follow that? You have to read these graphs, no problem. All right? Okay. So here, yep, the steeper is the slope, the higher the density, smaller the slope. The lower the density, in Andrew, we don't have changes, but we don't have angles in good density plots because density does not change. The only time that density is going to change is for a specific substances if you change its temperature. Right? Getting something warmer, getting something cooler is going to make it more or less dense. Higher temperatures will make less dense. Lower temperatures will make it more dense. But assuming the temperature stays roughly the same, a piece of any of a substance, no matter how big, will have the same density. All right? And that's why the lines are straight. Questions? All right, so let's do some examples down here at the bottom. Now, first thing that I want to show you here before we get into this is when you see a graph like this down here, right away, you know, you always, and this is another thing I told you before, how I always write, tidal -2 when someone's missing a tidal, or whether you didn't label the axes right away. Another thing is you always extend lines through the axis. Always. So when I see these, what I'm going to do is go ahead and grab my ruler again. And extend it like this. And you can extend it on both sides if you like, but no matter what, you always extend it through the axes. Not the best, but we'll go with it. Okay, and then you can even do it on this side. Okay. And this is called I'll get this right here. Extrapolate. You're going to extrapolate the data. Right. When you extend that line, have you guys ever heard of that term? Extrapolate, where you have a couple points on a graph, and then you just make the line longer on either side with a ruler, because you're seeing what the trend is and where the data is going on either side. Right, and the more points that you have there, the better the extrapolation is. But as long as you have 2 or 3 points, you can extrapolate it both ways. Now, other thing that I'll say before we get in the answer to these questions is, what else do I see with this graph? I look at it and I say, okay, well, for one thing, let's label this. This is going to be substance 1, and this is substance 2. But when I look at it, everything seems to be good label and title-wise, numbers, but when I look at the lines, what do I see as a problem? Remember up here? Yeah. What? The points aren't what? Well, you could label the points. That's not necessarily required, but I'll remind you, what did I write up here? What did we write up here? What are the lines supposed to do? Pass through the origin. Look at these lines. They're not doing that, are they? All right. Now, it's not terrible, but it's not ideal. Ideally, both those lines would meet down there at 0, 0, because again, that's what makes sense. Because according to this top line here, number 2, when you have 0 volume, you're going to have like 18 grams of the matter, which again, doesn't make much sense. If we were doing real research, I would probably have people do it over again several times and get more data and see if we can't pull that line down some to make it more realistic. But sometimes you got to go with what you got, and this is what we're going to do for here. All right. So let's take a look then at number 1. 1A. Which of those substances has a greater density? Yeah.
Number 2.
Good. Number 2, right? Because, whoops, let me change this something better right now. Why do you say that, Braden?
Because it has a higher density and it's at the top of the line.
Right, it has a larger slope. That's all. It's a larger slope, so that means it has a larger density. Okay? Now, the second thing that we have to do is we have to find the density, right? And you're going to find the density by finding the slope of the line. Okay? And we're going to do that by taking some points here. And this is, again, this is not any different than when you found the slope of the lines, probably going back to your middle school days. It's no different, right? Because that slope is the density. So you got to, what you usually do is you pick out 2 points, right? Now, just a little bit of strategy. You can pick any 2 points you want along the line, anything along the line, really. But when you're doing this, I would suggest picking points that meet on exactly on grid lines. That way you don't have to worry about misreading it. Right? You don't have to worry about estimating between grid lines to see what the values are. So if I'm looking at line 2, I would probably pick this point and like this point. Because they both, in both X and Y directions, they're going to hit a grid line. And it's easy to read. You can pick whatever you want. If you want to make it harder on yourself, you could pick wherever. It's fine. But I don't recommend making anything harder on yourself than you have to. Take the safest, most efficient way to do it. So if we're finding the slope of the second line of substance 2, we are going to do, remember, it's y2 minus y1 over x2 minus x1. So for this point right here, what is the y value for this top point here? From the graph, what does it say? 120. Okay, and then what's the x value? 4. Okay, now for the second point, what's the y value? 60. And then the x value is 2. So then that's going to be 60 grams divided by 2 milliliters, or 30 grams per milliliter. And that's our slope. That's the density of that object. All right. Just by comparison, water is 1 gram per milliliter, so that's a really, really dense substance. You have a gallon of water, then a gallon of this would weigh 30 times as much. Be really heavy. Okay. So I'm going to go ahead and write that in here, 30 grams per milliliter. Again, when you do this on a quiz or test, show your work. Make it pretty, make it obvious what you did. That way, if you make any mistakes, you got a little bit of an insurance policy. Okay, so then obviously the number 1 has the lower density because it's a smaller slope. I'm going to do it the same way. Again, we're going to pick points that make life easy. Boom, and here. Those points. Okay, so then the first one, what's the y value for the first point? What do you think, Elena?
40.
40. And what's the x value, Elena? 4. Okay. Then what's the second point y value? 20. And then the x value is 2. Okay, and that equals 20 over 20 grams over 2 milliliters, which is 10 grams per milliliter. And that's the other density. Got it? Everybody happy? All right. Let me write that in there. And that page is done. Okay. All right. Questions on that before we go to the final page of this? Everybody got it? Okay, let's move on. Last page here. I don't know what happened to 1 and 2, but there's 3. So, okay. So Daria, what do you think about number 3? What is the mass of 5 milliliters of substance 1? And substance 1, by the way, is the bottom line and 2 is the top. You have 5 milliliters of substance 1. That means how many grams? About 50. Okay. Now, when you do this, quiz test, either you're going to have multiple choice and it'll be obvious. Like for that, I'm not going to put 50 grams and then 51 grams. That wouldn't be very nice. But it'll be obvious for multiple choice. But if you're having to write it out, anywhere from 47 to 53-ish would probably be fine. Because not exactly obvious that it's perfectly in the middle there. So in other words, don't stress about that. All right. So, all right, Ariel, what about number 4 there? What is the volume of 60 grams of substance 2? What's that? So 60 grams of substance 2 is right there. What volume is that? About 3 or 2? 2, good. All right. Bless you. All right, Evan, what's 5?
120.
About 120. So we got 4 milliliters. Boom, right there. 120. Okay. And then finally, 6, we'll end with Luke. $40 grams of substance 1 is 4 milliliters. Good. All right. Questions on that? All right, good. Last thing on your homework. Pay close attention to this or you're going to have to do extra work. If you look at this, go ahead and take this homework and see all these little boxes in here. Just go like this. No. Don't do that. Other than that, there's 2 graphs there. Do the graphs first and then answer the questions. Just some practice doing this slope, and then next time we'll hopefully be working on our lab. Any questions? All right, that's all I have. Good job.